So we want to do 11.3, number 65. And this is another one of those solve things, right? These come in kind of two flavors, your book. This is what I would call the easier flavor, which makes it harder for you guys to execute sometimes, because it's not so obvious. The other flavor is where you kind of do this conversion. So which way do you want to do this? Do you want to try the conversion way? Yeah.
The easiest way.
Okay, the easy way is to notice that log base 3 of 1 is something you can do. What's that thing asking about?
It's 3 to the 1.
Yeah, that's asking what power of 3 is 1? Really, that's asking 3 to the what is 1? 0 is the answer to that question, right? So I could just replace that object with 0 because they mean the same thing, right?
Oh, okay.
And then solving this is stupid easy,
Yeah.
right?
What I did was I set it to exponential form, but I didn't change the base.
Yeah, so if you convert to exponential form, right, you'll get 3 to the 2x plus 1 is 1, right? And then you need to somehow figure out how to make the bases the same. So you need to notice that that 1 is 3 raised to the 0. And then you can equate these two pieces.
That's where I messed up, because I did 3 to the 0, 2x plus 1.
Yeah, that won't work. Yeah, you need to get the exponents the same, right? You guys see that? Once the bases are the same, it's the exponents that are the same, not the exponent on the left and the whole right-hand side. You guys see that? Okay, so either way, out of this, you get to this statement of 0 is 2x plus 1. And then you can solve this by,
Solving for x. Solving for x, yeah.
so you get x is
Negative 1.
perfect. Cool. Questions, concerns? Let me tag an addendum onto 65 and 11.3, which is that this thing your book has done is a little bit unfortunate because you can always get this number on the problems in the book. If this number were one of those inconvenient numbers that's defined but messy, right? Like if I had log base 7 of 10 is 2x plus 1. Right. Remember we found out this number was defined but messy last time? Or 2 problems ago or something. What would you do with this? How about this? What kind of object is log base 7 of 10? Is there a variable in that thing?
7.
It's asking a question, right? But is this object as it stands, is there a variable in there? No. This thing's categorically a number, right? So if it's a number, you could treat it like a number. Like if I was treating this as a number and I want to solve for x, what am I going to do first? Not divide. Yeah, you might just like look at this and think, okay, I've got some number is 2x plus 1, right? So first things first, I should subtract 1 from both sides. So I'll get log base 7 of 10 minus 1 is 2x. Don't put this and that together, you can't. You guys see that?
Yeah.
This is counting whole ones, and this is counting some weird, funny numbers, right? And order of operations says I have to deal with this 10 first, right? Which means I'm going to log base 7 it. Then what would you do? 5 by 2. So you'll get some horrible thing, right? Log base 7 of 10 minus 1 over 2 is x. But that thing's a number, and that's as good as it's going to get. So you just circle it and move on with your life. You guys see this? This thing's a little bit like pi or e, right? It's a number for which I could find a decimal approximation, but the equal sign way to leave it is just to leave it in there. Is cool? This will appear more and more the further we move into mathematics. The numbers will become a little bit less convenient, and we'll have these kind of, well, really we mean to apply this function to 10, right? Cool?